Hi everyone, this is section 7.1, so we're starting something new called hypothesis testing. To introduce this topic, let's look at an example. So suppose we have a professor claiming that he is holding a standard deck of 52 cards. And he claims that 50% of the cards are black and 50 are red, so just a fair deck, right? Well, that's what's in an actual deck. And we want to test the claim. So to test the claim, we take a sample of 10 cards from the deck. Suppose this happens when we take that sample. We see the first card red, second card red, third card red, all 10 cards red, no black. So we get 10 red, 0 black. I think we would all be suspicious about the professor's claim, right? Let's look at the math. Like, what is the probability of that happening? If indeed the professor's claim is correct, what is the probability of observing this sample? So we know from probability that the probability of getting a red card is 50%, or 0.5. And so the probability of getting 10 of them in a row would be 50% to the power of 10, which if we do that by calculation, I'm getting about 0.001. So like a tenth of 1% would be the probability of that happening. So then what we could say is, based on that, this is the probability of it happening by chance. So we would probably say that the chance of that is so rare that it's more logical that the professor is not telling the truth. So we would say it's false. Right? And this is the nature of hypothesis tests, right? So what we're going to be looking at is a claim about a population parameter, maybe like a mean or a percentage or something like that. And then we're going to test that claim by taking a sample from the population, observing the sample statistics, and then deciding, are these sample statistics rare enough to say that this claim, original claim, is false, or is the evidence supporting the claim? And there's a lot of detail that goes into hypothesis testing, and that's what we'll get into now. So a hypothesis test is a statistical process that uses sampling to test a claim. So when we state hypotheses, there's two of them, right? Because there are two opposing arguments here. For example, in that previous one, the professor's claim was that the deck was 50% red and 50% black. The opposite claim would be that that is false. It's not 50% red and 50% black. So those two hypotheses have specific names in statistics. The null hypothesis is the symbol H sub 0. Sometimes I'll just say HO for short, but it's actually a 0. That always contains equality. So you're always going to use one of these symbols when talking about the null hypothesis. So in that previous example, the professor says that the deck is 50% red. That would be equals 50%. That would be a null hypothesis. So the professor's claim was a null hypothesis. The alternative hypothesis is the opposite. So it's going to be one of these three, right? For example, if the null is greater than or equal to, then opposite of that is just less than, right? There's the opposite of that one, there's the opposite of that one. So they're just going to be opposite symbols. In the professor example, it's the not equal, right? The deck does not have 50% red cards. Now, HO or HA could be the claim. It just depends on the wording of the problem. So to write the null and alternative hypotheses, it does depend on the wording in the problem. So here's a little helpful table maybe that will help decide what symbols to use. So here are some verbal statements for HO, the verbal statements for HA, and how the mathematical statement will look, HO and HA. So that middle column is going to be our goal. We're going to take the wording of the problem and create two hypotheses using mathematical symbols. So that's what we'll practice next, or first, I guess. So let's try it. A car dealership claims that the mean time for an oil change is less than 15 minutes. Okay, so less than, that is an HA, right? Because it does not have equality. It doesn't say less than or equal to. And if I'm not certain, I can always go back to this. Here's less than, right? That's an HA. And that's the symbol for it right there. Okay. So less than 15, and it's the mean, so I'm going to write, typically when you write these, you put the HO first, the HA second, and you put a colon after them, and then you write the statement. So the first thing I look at is the wording mean less than 15. We know that's an HA, we just explained it, and now I just write it. And I'll even put in parentheses, that is the claim. For the HO, I'm just going to do the opposite. So it's mu and 15 still. Just the opposite of less than is greater than or equal to. And that's it. Okay, so this is just practice writing those hypotheses. This is going to be the first step in all of our problems for the next 2 chapters. How about a company advertises the mean is 18? So mean is 18. Okay, that one you might already know, but if I look at is equal to, right, that's an HO, and then there's my pairing. Okay, so that's how I can use that table if I want to. Or I just know mean is 18. Okay, so I can write my HO, HA. Because it's equal, that's got to be an HO. So mean equals 18. That's the claim. And then the HA, the opposite of equals, is not equal. And then there you go. How about a company claims that the mean life insurance, or not life insurance, life of its tires is at least 40,000. Okay, here's the issue, because there's going to be so many ways to express inequalities in the English language, right? So, but it's always going to start with this, HO, HA. I got to just decide, is this an HO, is it an HA, and how do I write it? So at least is that number or more, right? Or I think at least is on here. There's the at least. It's under the HO category, so this is what I would use. So instead of K, I just use the 40,000. So at least is mu greater than or equal to 40,000. At least is greater than or equal to. That is the claim. The opposite, less than 40,000. Okay, so there we go. Okay, now once we have that, we can start branching out into other types of population parameters. Those are all means, but we could have claims about standard deviations, about proportions, all kinds of things. So here are some other examples. Same thing, but now we just want to use the appropriate symbol. Okay, so a polling company claims that the proportion, so if it says proportion, we're going to use P. So now we're going to have HO, HA. Just make sure to use P for proportion. And this one says is different from. Is different from means not equal, right? Look back at that cheat sheet if that helps. Not equal to 40%. HO would be equal to 40%. In this case, the HA is the claim. Okay, the next one, standard deviation. There's a claim about a standard deviation. Is at most. Okay, so I know how to set this up. HO, HA. What's your symbol for standard deviation? That's sigma. And then at most 0.25. At most would be that number or less, or usually they're here, right? So at most is right there. Here's your pairing. Right. At most is in the HO column, and so I know what to do. Okay, so at most 0.25 is the claim, or greater than is the opposite of that. And then finally, that professor's example, those we're talking about proportions of cards in a red deck, right? And so we already kind of verbalized that one. The professor's claim was that it was 0.5. The HA was that it's not. Okay, so we got that one. Going further now, once we have that, how do we perform a hypothesis test? Well, after hypotheses are stated, we draw a random sample, right? So a random sample is drawn, and statistics are calculated, and then they're going to be used to make a decision about the claim. So before the sample is drawn, here's a fact that we'll need. We always assume that the null hypothesis is true. So here's the structure of hypothesis testing logic. So based on the data from the sample, you'll make one of two possible decisions. Either we're going to reject the null or fail to reject the null. It's always one of those two. And notice it's always the null hypothesis. Remember, the null hypothesis is HO. So we reject HO or fail to reject, which is like a double negative. Fail to reject. It's not necessarily supporting, it's just we're not rejecting. Okay. Now, that decision is based on the comparison of two values, the level of significance and the p-value, which now we have to introduce those two. So the level of significance, this will always be given in a problem. And it's our marker in the sand for unusual events. Like up to now, we've been using like 5%, but it could change. It's not set in stone, right? So it just what the researcher entails. Or what the research entails. So some common values are here. 5% is probably the most common one, but you could do 10 or 1 or anything, right? But that's always given. And then a p-value is the probability of obtaining that sample statistic or more extreme, right? Like if you go back to that the problem with the professor, right? What was the probability that we obtained 10 red cards in a row? That's called a p-value. That percentage that we found, that probability, that was our p-value. So it's that probability of seeing those sample statistics or more extreme. So more extreme just means like you're looking at like a tail of a normal distribution, really. Okay. And then you make a decision based on the comparison of those. So if the p-value is small, right, that means smaller than the alpha. Alpha, by the way, is the level of significance variable. So if the p-value is smaller than the level of significance, then we reject, right? So if that p-value we're saying is unusual, that sample is unusual, then we're going to reject the null hypothesis. Our logic is saying, if that null hypothesis is true, this would be a very rare sample. Therefore, that null hypothesis is probably not true. And then if the p-value is larger, then we're good. We're just not going to reject the null hypothesis. And then finally, we're going to make a decision. Right? So we'll interpret our decision with one of these four ways. And it kind of depends on which one is the claim, HO or HA, and did we reject HO or fail to reject HO. Right? And so this is just the logic of it, right? So it makes sense here. If HO is the claim and we reject HO, then we found evidence. Right, there's sufficient evidence to reject. Okay, but if we if we fail to reject, then there's insufficient evidence to reject. Okay, and then two similar ones over here. Right, so you usually end up with one of those four final statements. Okay, let's tackle one more page. This is kind of a long section, so I'll break it up into two videos. Okay, so now let's mess around with some p-values here. Based on the information given, make a decision about the null hypothesis and give a final conclusion. Okay, so we still have to start with our HO and HA, like we've done before. All right, the mean price is less than 26,860. That's an HA, do you notice? Because it just says strictly less than, does not have equality. So there's the claim. Greater than would be the HO, and there we have it. Okay, hypothesis test is performed. Alpha is 0.05, and then the p-value is 0.025. So the alpha is always going to be given. The p-value, eventually we're going to calculate these, but for now we're just jumping through over that and just giving the value. So what do you think? Should we reject or fail to reject the null hypothesis here? Well, let's compare those values. We have p is 0.025 compared to alpha 0.05. Right, so notice that the p is smaller, right? It goes this way. So since the p is smaller, remember what that meant? Reject h sub o. That goes back to this right here, right? It's that first bullet point. If the p-value is smaller than alpha, then we reject HO, okay? So that's what we did. We rejected HO. Now, what is our conclusion? Well, let's put those two things together. HA is the claim, and we rejected HO. In other words, we just rejected the opposite of the claim, which in turn says, oh, well, then we can probably support our claim. Or look at your little conclusion table. Reject HO, HA is the claim. Right. Reject HO, HA is the claim. That leads you to this one right here. There's sufficient evidence to support the claim. Okay, now just write that down. So, there is sufficient evidence to support. Really sloppy writing. The claim. Okay, so that's the idea here. So it's really important to know which one is the claim, HO or HA, and then decide reject HO or fail to reject, and then use your table at the end. Here's another one. A research organization reports that 28%, so now we're using P's, and that sounds like an equal. So P equals 0.28 or 28%. And that is the claim. HO would be just not equal. Okay, so there's the structure. And then we have alpha 0.1, and the P is 0.125, alpha 0.1. So notice the P is bigger, right? If you just think of it as 0.100, 125 is bigger than 100. Okay, so here we have P is larger. So this is fail to reject HO. So HO is the claim, and we couldn't reject it. What do we do there? Okay, let's get rid of this mess we have in this one now. HO is the claim, and we failed to reject HO. There's our answer. Insufficient evidence to reject. Okay, so there's insufficient evidence to reject. Or not enough. Of course, in English, there's lots of ways you can say this. But there we go. Okay. Let's do one more. How about the light bulb claims the mean is more than. Okay, so back to means, and strictly more than is an HA because it does not have equals. So here the claim is the HA. HO, flip it around, put an equals on it. So there's the setup. If we compare our values here, looks like, yep, P is smaller, right? 0.005 is less than 0.01. It's like 1% compared to 0.5%. So P is smaller. So that leads you to reject HO, and HA is the claim. So that's similar to the first one. Right? There's sufficient evidence to support. Okay. So I know it's a lot at first because there's a lot of technical lingo and things to kind of weed through here. But practice with this and it'll come pretty okay once you get used to it. Okay, I'll stop there for now, and then I'll continue and finish off 7.1 in the next video. Okay, hope all's well. Talk to you later.